Okay, how's everybody doing? Good. Um, so before we get into the real stuff today, have any of you received invitations to do the what is it? The teaching evaluations? Okay, so you get them by email to your Connect account. If you don't read your Connect account regularly, check it for this. So I know from previous experience that students don't really know what these things do. So there's basically two parts to the teaching evaluations. There are some numerical scores, and these things get used for things like promotion and tenure and basically career development things. So if at some point I'm being evaluated for a promotion or I'm being evaluated for tenure, then these scores get used. So this is part of the stuff that I submit as my application for this thing. Now in my case, I won't be going up for tenure anytime soon because I got tenure a long time ago, and I won't be going up for promotion anytime soon because I got promoted to full professor this year. So the teaching scores don't matter much to me. So put whatever you want there, be honest, just whatever you think. So these are used for evaluation purposes. What matters to me more is this free-form comments section. So these things actually, this is what students are often confused about. Nobody reads those except me. So, so if you're writing these things, really you're writing them to me. So I know that students are confused about this because they'll write things like, oh, the professor is too tall and he's funny looking. When really they should be writing, you are too tall and you're funny looking. Because I'm the only person who reads these things. But really what I would like to see there is any feedback you have for me about this course. So do you like the format? Do you like the fact that we have videos available? Do you like that we have an assignment every week, or do you wish that we could have bigger assignments but not so frequently? All of these things are things that I want to know. They're things that I can use to improve the course the course in the future. But both of these things, whether it's the numerical scores or the free-form comments, these things are not publicly available. So nobody else, the numerical scores I'll get to see, and they could be used if they try and fire me in a couple of years and say, look, you're such a bad teacher, and here's the proof. And the free-form comments are used by me to maybe help improve the course or to give some feedback to me. The free-form comments actually, typically we receive these things about 1 month after the course is completely over. So exam is over, all the grades are submitted and everything. So be honest. There's nothing I can do to you after that point. I can't hurt you anymore. And besides, they're anonymous comments anyway. But what I like to do actually is make a news forum post with the things that I read the most commonly from students. Just so you guys get some idea of, some idea of what other students think, and you see that I indeed am reading these things and trying to take them into consideration. Unfortunately, what often happens is the most common comments are contradictory. So I'll get a lot of comments that say, I really like the fact that you program in class, and then I'll get a lot of comments that say, oh, I really wish you wouldn't program in class, I wish you would use slides. And so then it's difficult to make a decision based on that. Or I really like that we have an assignment due every week, and a whole bunch that say I don't like that we have an assignment due every week. So those sort of balance out, and then I have to do whatever I think is best for your learning. But I'll summarize these and post them later. But actually, probably the most useful thing you can do for future students is to do these teaching evaluations fine, like you're supposed to, but also go to Rate My Professor. So any of you heard of this site? So it's a website where you can go and list the course and the name and the professor you took it with, and those get all grouped together by professors. And say whatever you want there. And again, it's anonymous. There's no names of the students visible, or it's as anonymous as you want it to be based on your comments. But what it's useful for is that this is a public forum, and students in future years can look at this thing and decide, I see there's 2 sections of 1405. One is being taught by Morin, the other one is being taught by someone else, and everybody really hates Morin, so I'm going to take this other section. That's probably the most useful thing you can do for future students. Okay. So be good students or be good citizens and do your teaching evaluations. Okay. Now, last class we had a guest. You guys had a guest lecturer. There is a video of that, so it'll get posted later today. Did you have any questions you wanted to ask me about some of that material? Yeah. You can't open a Java. So you mean you can't run a Java program in PowerShell, or you can't compile a Java program? Okay, so if you remember when you set up Python, early on there was some little instructions for how to get Python in your path in PowerShell. So that was in this, I think we can probably find it. Learn Python the hard way. And it was in exercise 0. Okay, so step 4 here, this is for Windows. After you install Python, it still isn't recognized in PowerShell, then enter this. And then there's this piece of code here that basically sets up your environment so that the Python home directory is in your path. So just do the same thing, but do it with the Java home directory from the Java installation. So it'll be in something like C drive program files, Java bin, somewhere in there. So find the directory that has java.exe and javac.exe, and that's what you'll put here instead of C drive Python 27. Anybody else having that issue? Okay, good. Okay. Any other questions? No. All right. So let's learn a little bit more about Java today, and so we'll start by writing a program. So what's the first thing we have to do if we want to write a program in Java? So what's the first rule about all code, all programs in Java? Yep. Has to be inside a class. Okay, so here I have a file called today.java. So what does the name of my class have to be? Today. So I have to create a class called today, and I want this to be a public class, meaning that anybody can use this class. So it's not just restricted to special other classes or special locations. Anybody's free to use this class called today. And if I want to make today be a class that's runnable, what do I have to include in it? So you won't get anywhere unless you can do this. Yep. You have to include a main method. A public, static, void, main method that takes one argument called args, which is an array of strings. So just a reminder what all these things mean. Public means anybody can use it. Static means it doesn't have to run on an instance of this class. It's just a method that's held inside this class, but it can be run without actually having an instance of this class. So we don't need a today object to run this method. Void means that it doesn't return anything, or doesn't return any special values. And main is the name of it, and it takes one argument, which is an array of strings. So this indicates that it's an array. This tells what goes in the array, and this is just the name of that argument. You can change the name of the argument if you want, but everything else about this method has to be exactly like this. So you could change this to argx if you wanted. Okay. All right. So one thing that we saw, or that you should have seen, is while variables in Java have to have types, so if I want to declare a variable called n, I have to decide what's going to go in that variable when I declare it. And so let's say I want integers, and I'll initially set it to 10. And if I wanted to, for example, make an array of strings, that looks like this. So this is the string array notation, and we'll call this array A. And well, there's a couple of things we can do. We could say, make it full of literal strings like this. So that's an array that contains 3 strings. Or we could say something like, here's an array that is an array of strings, and I would like it to contain n strings. So in this case, it'll contain 10 strings. Okay. So both of these things create arrays, and arrays are a little bit like the lists that we saw in Python. So for example, I can iterate over arrays. The usual code for that looks like this. It's a 3-part for loop. First part starts setting the counter to 0, and as long as the counter is less than the length of the array, we continue this loop, and at the end of each iteration of the loop, we increment the value of the counter. So this just goes through with the counter from whose length is well, the length of the array, so 0 up to the length of the array minus 1, and then it prints the value of the array at that counter. So let's try that. So indeed, this does what we think it does. Okay, so I wasn't here for this last lecture, so I need to know, do you have any questions about this? This should all be fairly reviewy type stuff. Okay. So for those of you who have programmed in Java before, what's the difference between Java's arrays and Python's lists? So I know a lot of you have programmed in Java before, yeah?
Array in Java, you set the length first, and when you have that case, the array always depend on your, on the initial. When you set the array to equal n, this array always be equal n. You never to change it unless you make another new array.
Yeah.
Array kind of clone or copy whatever.
Yeah. So an array in Java the main limitation to it is when you create it, you specify its size, and then that's it. The size is fixed forever. So for example, in this array A that contains 3 strings, there's no way for me to delete one of those strings. I can go ahead and change one, but I can't get rid of it. There's no delete. So for example, I can't say, you know, a.remove position 1 or anything. There's nothing, no way to do that. The best that I could do is say a at 1 equals null. So this is just a special value that says there's nothing there. But if I do that and print it out, then you know, there is still an entry there. It's just that its value is null now. So it's not a string, but it's still there. It doesn't really take it out of the array. So I can't make the array shorter, and I can't make it longer. Once I've made it, its size is fixed. The best that I could do is to create a new array which is bigger or smaller, and then copy everything from the original array into the new array. So that's a big limitation of arrays in Java, and in general, arrays in most programming languages. It's only really Python that dodges arrays entirely and makes these things called lists, which are just like arrays, but they can grow. Now, there is something like lists in Java, so something like Python's lists, and in fact, they're called lists in Java. But before we use them, I want to talk a little bit about something that's present in Java, but not needed in Python. And that's this notion of something called an interface. So let's take So let's Google Java's lists. So we see that in the Oracle documentation for Java, we can find this thing called a list. And it's got this funny notation here, list E. Well, lists are like arrays in the sense that, you know, they store things by position, but also in the sense that when you create a list, you have to say what goes into it. Right? So when we create an array, we have to say whether it's an array of strings, an array of integers, an array of floats, an array of doubles, whatever. Well, the same thing is true with a list. And the way we do that is we use this funny diamond notation to specify what kinds of objects go in the list. So for example, if I want to make a list of strings, that looks like this. So that declares a list of strings called L. And we can look at the things that lists can do. You can add an element to the list. You can add an element at a particular position. You can add a whole bunch of elements. You can empty it. You can do all kinds of stuff. And we'll look at a few of these. You can ask for its size. You can change the value of an element. You can even get a sublist. So this is a bit like a slice in a Java or a Python list. But a list is just an interface. So it just tells you what you can do with lists. Now, it doesn't tell you how it's done. It just tells you the operations that a list supports. So when you actually want a list, you have to decide not on an interface. I mean, you know the interface, you want a list, so you know what you want it to do, but you have to pick some class that does those things. And that's just what they call an implementation in Java. And for us, the lists which most closely resemble Python's lists are array lists. So you can look at the documentation for array lists. And there's a funny thing that's noted there. It says that you know, there's a class called array lists. It shows you where this class fits in some inheritance hierarchy. and it says that it implements the list interface. So that means we can use an array list like a list. We can also use an array list in other ways, but one thing that we can use it is just like a list. So this list L that we're creating, we can say, well, I would like it to be a new array list of strings. Now, in Java, like in Python, some things are built in. There's a few simple things built in. Strings are one of those simple things, arrays and all of the basic data types. But lists are something that you have to import. So if you go back and look at this documentation, you'll see that this thing is really called java.util.ArrayList. So it's something that's part of the java.util package, so we actually have to explicitly import it. And even list is a is in the java.util package, so we have to import that as well. So we have to say import java.util.list and import java.util.ArrayList. Okay, so that creates a new list of strings, and we can say, for example, now that we have this list, we can add a few strings to it. And then print it. Okay, so this is this list that we've just printed. It contains first string, second string. Those are the two strings that we added to this list in the order we added them. Okay. And you can do, you can add things to lists. So this is basically, this is like Python's list.append, so this adds it to the end of the list. But there's another version of the add function that takes two arguments. The first one tells you where to add it. So for example, to add at position 0, this is what I do. So to the list L, add at position 0 this string here. And, oh, we forgot to print it. So compile, and run. Use larger font. Yeah, so we had this list with first string, second string, and then at position 0 we added a 0th string, which pushed the other two down one position. Okay? And of course you can index the elements of a list. So for example, if we want to just print out the elements of a list in some order, or go through the elements of the list in this particular order, we can say use a 3-part for loop where I counts from 0 up to the size of L minus 1. And what we would like to do is say L at I, but this notation here in Java only works for arrays. Yep?
What's the difference between the size and length?
Okay, so let's make some notes. Size versus length. Okay, so size is a method in the list interface, which means that we write things like L dot, this is So this is actually wrong. We write things like L dot size. So that's the way we get the size of a list. Length is a property of an array, which means we write things like a dot length. So a couple of things. So L is actually a function that you call. It returns you size is a function that you call that gives you back the length of the list. And length is just a property of an array that's stored alongside the array. So you just, so it's not a function, so there's no extra parentheses around it. So here, for example, this is how we got the length of the array. But when we're dealing with lists, we have to ask them for their size. And here, this piece of code won't work. We can compile it and see what happens. So it says there's an error in this line. An array is required, but it was given a list. So in Java, arrays are the only things you can use this subscript operator on. And the list is not an array, so we can't use that. Instead, there's a method called get, which does the same thing. So now that'll work. And indeed, so this is that for loop printing out the elements one at a time, one on each line. And along with a get, so this here is like Python's L at I. There's also a set. So this is like saying L at I equals $. So that array now just got wiped out. The 3 values are now gone, gone, gone. So the string gone. Okay, so here's an exercise for us then. Let's write a method called, so the method is like Python's range method. So it takes an integer argument and gives you back a list which contains the elements 0, 1, 2, 3, all the way up to n, or n minus 1 rather. So it takes this argument n, supposed to be an integer, let's say bigger than or equal to 0, and gives you back a list that contains 0 through n minus 1. So I want to write a function that does that, and I'll tell you that I want it to be a public function so anybody can use it, and it's a static function, so you don't need an instance of an object to use it. But now I'd like you guys to write the rest of it for me. So functions have to have a return type. That would be written right here. So what would the return type of this function be? A list? Is that specific enough? So these are all things you don't have to think about when you're writing Python code, but are actually important here. So is it specific enough to say it returns a list? Yeah. In fact, you have to put a diamond, and it's not int. but it's integer that you have to use. So I told you that there's all these primitive data types called int, float, double, all of these things. It turns out that in Java, lists and other types of containers, they can only hold objects. And so in Java, we had int, float, double, short, long, all kinds of these things. There's a whole bunch of related classes which are called integer, float, double, short, and long, using capital letters, that if you want to make a list of integers, for example, you make a list of these integer objects rather than the basic integers. So this thing has to return a list of integers. Okay, so we've got the function prototype, or we've got the definition of the function correct. Now we just need to say what happens inside of it. So how would I make this thing produce a list of integers? So what's the first thing I should do? What's that? Okay, so I should make a new integer list, because that's what I'm supposed to return, so I'd better make one. We can call it L, and well, we've done something like this before, where we said L is a list of integers, and we want to make it, we'll create a new array list. So that looks like this. Okay, and now what? So now we've created this empty list L. What do we do? So we'll create a 3-part for loop that should look like what? So it'll start at 0, and it'll continue as long as I is less than n, which means it'll go up to n minus 1 if n is an integer, and actually n has to be an integer. And at the end of each iteration, the value of I will increase by 1. Okay, and what do we do? Yeah, so L dot add I. So let's test this thing. What's that? Yes. And finally, once we're done making it, we return it. So let's see if it works. So this will call range of 20, which should give us a list containing 20 values, and then we'll print it. There you go. Okay. And just as an exercise, see if we can do it a different way. So same thing, we create a list, we're going to populate it, and then we're going to return it. So if I didn't want to use a for loop, I just wanted to use a while loop. Is there another way to do that? Yeah.
You declare I at the start of your method.
Even without declaring a variable I.
While L dot size equal of less than n.
Yep.
And L dot add
Dot add what?
Oh, sorry. Before L dot add something, you need to set a value with I, and then L dot add I plus plus.
So even without the variable I. Yep.
The value of the cell.
Yep.
Yeah, that's yeah.
So there's another way to do it. So we'll call that thing range 2. So this one avoids keeping the counter I because really L is already keeping a counter, which is its size, which is good enough for us. Yep.
I was wondering if there's a way to do like something similar to Python's interaction mode in Java, so you don't have to.
No. There is no interactive mode in Java. There are a few integrated development environments that can give you something that's a little bit like an interactive mode, but not really. And so no. Yeah, the short answer is no. And that's a reason that I don't like to teach introductory programming using Java, because it's clunky, right? So we can try it with range 2. So once you've used Python, Java feels clunky and heavy, and this lack of interactive mode, this compiling, even the amount of work that you have to do to get things done, right? So here's a function that, maybe it's not fair because in Python you would this is already built in, but even if it weren't built in, this would be the same thing, well, yeah. This would be a lot easier to do in Python, or somewhat easier to do. So it's not a great. Java is what it is, and you're going to learn it eventually, and maybe you'll even have a job where you program in it. But there you go. Okay. So I can tell you a little bit more about all the bad things with Java shortly. But okay. So there we've done that. There are some things that have been useful to us in Python, and those were, for example, I believe it was called random.shuffle, which is something that we used in Python to shuffle the contents of an array or of a list. And in Java, you can get the same thing. So there's a whole class called collections that's worth taking a look at. So it can do a whole bunch of things to different kinds of collections. One of them is to shuffle a collection. So you can give it a list as an argument, and it'll randomly permute the elements of the list. So for example, let's say list integer L2 is equal to range 20. And I can say collections.shuffle L2. So now this thing should be randomly permuted. You can take a look at it. Indeed. So this started out as a list that was in sorted order. Now it's been randomly permuted. So this is the equivalent to random.shuffle in Python. We have also seen sorting in Python, which you can get with this is like equivalent to a.sort in Python. So this is like taking L2 and sorting it. If we had a list called L2 in Python, we would say L2.sort. So it started out in sorted order, we permuted it, and then we sorted it again. So there's a useless piece of code, but at least now you know how to sort things. And there's even one that I don't think is available in Python, but is easy to write, and that is reverse. This is like so now instead of counting from 0 to 19, it'll count down from 19 to 0. So this is the sorted list. When we reverse it, we get this list. So some handy sort of utilities in there. You know, if you're looking to do something to a list that reorders it or something in some way, have a look at the collections class. There's a lot of different types of things that it can do, and it's maybe easier than writing it from scratch. And of course, something else you can do to lists, and I would like to demonstrate this maybe with our list of strings here. So by this point, we have a list of strings that contains 3 elements, 0th string, 1st string, 2nd string. Print it and see those 3 elements. Lists also have a remove method. And here you have to be careful to know what this means. What you specify is not the value of the element that you want to remove, but the index of the element you want to remove. So if I remove the element at index 1 in that list, right, so we had 0th string at position 0, 1st string at position 1, 2nd string at position 2. Well, when I remove the element at position 1, I get a new list that has only these strings here. Okay, so it really, this is the thing that removes a list, an element from a list. The other elements close in to fill in the gap. The list gets smaller. So you can add or remove from these lists at any location. One thing I would like to point out is for the sake of efficiency, it's not wise to add or remove except near the end of the list. So anytime you add or remove near the beginning of a list, everything else in the list either has to get pushed down to make room for the thing you're adding, or it has to get pulled back to make room for or to fill in the gap from the thing you just deleted. That's a slow operation. So it's okay to add and remove at the end, but not at the front. That'll be slow. Okay, and then finally, there is a sublist operation. So let's use that on L2. Let's say list integer SL for sublist. That will be L2's sublist from index 10 up to, but not including, index 15. So this is a bit like A at 10 to 15 in Python, or in this case, this thing is called L2. So it's a bit like taking a slice of this list from 10 to 15. Yeah, so here's position 10 in the list, and position 15 would be this number 4 here. So we get the elements 9, 8, 7, 6, 5. So up to, but not including the element at index 15. Okay, now I say this is a bit like a slice of a list in Python. But this looks exactly like what happens in Python, right? This Python, you do this, you get exactly this thing. Is there any Java experts here who can tell me why it's not like what happens in Python? Yeah?
It's inclusive.
No, it's not inclusive. So this is position 10, 11, 12, 13, 14. And then this is 15, so we didn't include 15. So it's not inclusive. So the indexing is exactly the same as a slice that you do in Python. No, nobody knows the difference? Okay, it's good that I pointed out because it's a source of can be a source of very difficult to track down bugs. Let's do something like, say, this sublist, let's set the element at position 2, and let's set it to 100. Okay, so you've seen now what the sublist looks like. When I set position 2 to 100, what's the sublist going to look like? So this is SL, and I said, SL, take the element at position 2 and set it to 100. So what's the list going to be? It's not a trick question. What's that? The third one, yeah, so the value 7 here is going to be changed to 100, right? Let's check to see that we understand that. Okay, that's no surprise, right? This is the element at position 0, the element at position 1, and this is the element at position 2, so that changed. Okay, so this still looks just like in Python. Can anybody guess what I can do now to show you something that's different from Python? Yep. Print the other list. Let's go back and print L2 now. Whoops, L2 has changed. This number changed to 100. So when you do a sublist operation in Java, that's actually a very fast operation. So it doesn't copy the list. It just makes a little view of the list that includes only those elements that you're interested in. So here I made this sublist that contained elements at positions 10 through 14. And those happen to be 9, 8, 7, 6, 5. Now, that's just a view of a little part of this bigger list. So when I change something in this little list, I'm actually also changing it in the bigger list. And if you're not expecting that, well, that can really mess things up. So the sublist operation is more efficient, but it means that you now have two lists that share the same data. So if you really look at what's, the best way to understand that is through a picture. We had this list L2, which had 0, 1, or it counts down from 19, 19, 18, 17, 16, 15, 14, 13, 9, 8, 7, 0, So that's L2. It's just some object that points off to some list. And then SL, when we create it, it's actually an object that goes and points off here to 9. And it remembers a couple of other things. So basically it remembers its starting point and its length, and it knows that it starts at 9 and goes and has length 5, so it goes up to that position there. Okay. So when I change something in SL, I'm also changing something in L2. That can cause problems if you're not ready for it, or maybe it's exactly what you want. One nice feature about this is it's really fast. So if you remember, when we were implementing binary search in Python, the first thing we tried is saying, let's just take the slice, we look at the middle element and we decide that means we have to look at the first half or the second half. Let's just take a slice that contains the first half or a slice that contains the second half. That ended up being too slow. In Java, that wouldn't be too slow because this sublist operation, all it does is creates a pointer into an existing list and remembers how long it should be. So it's just a constant time operation instead of one that copies everything out of the list. So there's a trade-off there between being fast and having this weird behavior if you start changing things versus copying everything, which means you're slow, but nothing strange happens. Okay. What else does Python have that we might like to use in Java? Well, it has sets. So this is like Python's lists. This is an implementation of Python's lists. This is just some utilities. And this is like Python's set. So again, a set is just like we had in Python. It's an unordered collection of distinct elements. So for example, and to create one, like everything in Java, you have to specify everything right down to the last detail. So when I make a set, I have to tell you what goes into it. It's going to be integers. And just like we had with lists, set is just the name of an interface. It just tells us what this thing can do. If we want an implementation, we have to go looking for one. And it turns out that there's one called a hash set. That's an implementation of sets. It's actually just like the one in Python. So it supports all of these adding, removing, and looking for things in constant time. But we have to import it. So we'll create a hash set of integers, and we can add a bunch of stuff to it. So let's say for the integer x in the range 20. Oops. And we'll call our set s. We'll say s.addX. Mr. Bracket. There. Legal start of expression. Yep. Equals new hash set. Anytime we want to create a new object, we have to use the new keyword. Okay, so yeah, so there's our set that we created, and notice that it is not exactly in the order that we created it. Pretty close, so it starts out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then it kind of falls out of order here, but that's okay. Sets don't guarantee anything about order. They're supposed to be unordered, so this one is kind of the same order we put it in, but we can't rely on that. And certainly it's not exactly the same order. So adding to a set is really fast. And then we can ask questions like, we can say, does it contain 12? Or does it contain 22? So there's our set S. Does it contain 12? The answer is true. Does it contain 22? The answer is false. And of course we can remove things. So we can remove 12, we can remove 0, so after we remove 12 and 0, indeed 12 is gone, it's not there anymore, and 0 is gone too. So these are the things that sets are good for: adding elements, removing elements, and checking if something is in there. So that's the add operation, the contains operation for checking if something is in there, and the remove operation for removing things. So they can do all those operations in constant time. Okay. What else? So any questions so far? So what else do we have in Python that we haven't seen yet in Java? Nothing? Nothing? We can do it all? I can think of one thing. What's that? Graphics? Yeah, we won't be doing graphics. That would take too long. But you will be doing graphical user interfaces next semester. So dictionaries, that's right. So, so what about Python's dictionaries? So we've seen their lists, we've seen all the basic data types, we've even seen sets, but what about dictionaries? Well, it turns out that Java does have dictionaries, but they have a different name. They're called maps. And that's because Java decided to go with more mathematical terminology for those, and Python liked the more colloquial terminology. So there's a thing called a map. So remember what dictionaries do. They allow you to, and this is why these things are called maps, they allow you to take keys and map them onto values. And it doesn't matter what kinds of keys you use, so it doesn't just have to be integers like what happens with lists, but any kind of key, and you can map it onto to any kind of value. So that's what dictionaries do. And just like lists and just like sets, there's the interface which says what this thing does, and then there's the implementation. So in this case, the interface is the map interface, and the implementation is the hash map implementation. So I want to declare a map. So when I declared a list, I had to say what kind of elements the list stored. When I declared a set, I had to say what kind of elements the set stored using the diamond operator. For a map, is it that simple? Yep.
You have to define the type of the value and the type of the key.
Yeah, so maps really store pairs of things, right? They store the key and then the associated value. So I actually have to tell you what both of those things are. So for example, let's take a map which maps strings onto integers. So that'll create one of these things. And now we'll call that thing M. So the way you add things to a map is you put them. So I could say at the string Pat, put the integer 40. At the string Jeff, put the integer 46. And at the string George, put the integer 102. So let's take a look at the resulting map. So this shows me a map where Pat gets mapped to 40, George to 102, and Jeff to 46. So great. So what are dictionaries fast at doing? And so, you know, what are dictionaries for in Python, really? Or what are the fast operations? Or what are dictionaries for in English, and what are the fast operations? Yeah.
Get the value of the key.
Yeah. So we can get the value of any key. So the way you get the value of a key is by using the get method. So if I get the value associated with Pat, it's 40. So that's a really fast operation. And you can also change the value using put. So I'll change the value at Pat to 41. So that changes it, and I think you can even remove keys. Okay, so it's not called remove key, it's called Java map delete key, or just remove. just remove, okay. Okay, so just remove will, just like for lists, you specify the index of the thing you want to remove or the key of the thing you want to remove.